Hi everyone. I am a chemistry and math teacher. I teach in Alberta, Canada, so I follow the Alberta's curriculum. I would just like to share my first lesson on electrochemistry, where we introduce electrochem reactions, which we call redox reactions, and we learn concepts like oxidation and reduction. I will post the next lesson to this and continue until we get through the unit. I hope you find this helpful. So the first part is just talking about what electrochemistry is, and the whole basis of it is about electron transfer between species in a reaction. Moving on from here, just knowing how it's used, it is used in many processes. You probably just don't even know some of the reactions that do take place, that they are redox reactions, like metabolizing food. Corrosion of metal is a part that we'll talk about further on, which is in the curriculum. Batteries, voltaic cells, electrolytic cells that fall in batteries that we'll look more into, and electroplating of metals is also a big part of the curriculum for Chem 30. Moving on, the part that we talk about here is the oxidation reactions. And when we're looking at oxidation, it says the process by which electrons are removed. So there are a couple acronyms you could use here. There's one for LEO, loss of electrons is oxidation. When I was in high school, I learned OIL, so OIL, where I would read it as oxidation involves loss. So meaning if you have an oxidation reaction, you are losing electrons. So this one we see here, this is a half reaction. And if you take a look at what's happening to copper, copper solid is turning into copper 2 positive in the aqueous state. So for copper to become 2 positive, it would have had to lose 2 electrons. And one of the other ways you can tell that 2 were lost is that you see it on the product side. So copper got split up into copper 2 positive, the ion, and 2 electrons. When you're looking at what's undergoing oxidation, you always refer to your reactants. So copper is undergoing oxidation because it lost 2 electrons. Now, when you're looking at reduction, which is the other type of reaction, there is that acronym GER, where it stands for gain electrons reduction. The opposite to oxidation is reduction. You're adding in electrons. And again, when I was in high school, I learned the acronym RIG. So this stands for reduction involves gain. So when we're looking at this iron with a positive 2 charge, it is going to gain 2 electrons to become iron solid. Or if I just look to compare Fe2 positive to Fe solid, it went from a positive 2 charge to a neutral charge of 0. So to do that, you have to add in 2 negative. Sorry, my dogs are barking outside. Hope that's not too distracting. So there are the 2 acronyms. If you like the one about the lion, you could use that. If you like the one oil rig, that's one I'll always refer to because that's how I learned it and what I was used to. So there are a few examples here, just being able to identify. So here, copper going to copper 2 positive. Sorry about that. That would be a loss of electrons. So this would be oxidation. If we're looking at this next one, like our example, Fe2 positive going to Fe with a neutral charge, that had to gain 2 electrons. So RIG is reduction involves gain. I'm just going to write RED here for reduction. Here we went from Fe3 positive to Fe2 positive. So you had to add in 1 electron. So that's, again, gaining. So that's reduction. Coming down here, X2 has a neutral charge of 0. And over here, it's negative. So it's going from 0 to a negative. So you are gaining again. So that is reduction. And then this last one, Z negative 5 to Z negative 2. To become less negative, you had to you had to lose negatives. So that would be oxidation, because oxidation involves loss of electrons. When we're looking at this, and if you have a table, we do, I'm sorry, I'm jumping ahead of myself here. So when you are undergoing different types of reactions, if you're undergoing oxidation, they refer to you as the reducing agent. So that can get a little bit confusing because we're saying oxidation, but then we're using the word reduce. But it's just something we have to remember. And if you're undergoing reduction, so you're being reduced, you're an oxidizing agent. So when you're trying to identify what's being oxidized or reduced, I like to emphasize in class, you're always looking at your reactants. So don't look at your products. Products just help us see what's going on. Always look at your reactants. And then this last point down here where it tells you reactions in which an equal number of electrons are gained by one atom or ion and lost by another, those are oxidation reduction reactions, which are referred to as redox reactions. So all of our redox reactions are an exchange of electrons. So when we're looking at our examples and we want to be able to identify OAs and RAs, you do want to start with that balanced chemical equation. You want to know the solubility because sometimes we're going to break up compounds. We want to write an ionic equation. That's why we need to look at solubility so we know what we can break apart. We want to cancel spectator ions. So we need to be fairly good at net ionic equations. And then once we have everything going on within the equation, you can identify your OA and your RA. So your oxidizing agent and your reducing agent. So when we're looking at this and we're writing our ionic equation, this is just a reminder. You dissociate soluble ionic compounds, which means you have an ionic compound in the aqueous state and strong acids. So if you have a data booklet from Alberta, that would be on page 8 and 9, and it's above your gray line. So there's 6 acids above your gray line. And now what does not dissociate, meaning if you see it, you're not going to break up into ions or insoluble ionic compounds, which means it's an ionic compound with a solid state. Weak acids, so below the gray line on page 8 and 9, and then molecular compounds. We do not break them apart, they stay together. So let's take a look at an example. So here you have zinc metal reacts with a solution of copper 2 sulfate. So when you're starting off, we just want the balanced chemical equation. So zinc solid reacts with copper 2 sulfate. So copper 2 and sulfate is SO4, and it says solution, so you know the state would be aqueous. And this is just a single replacement reaction. So you'll end up with copper solid, and then zinc will come with sulfate. Zinc has a charge of positive 2, so with sulfate with negative 2, you just need one of each to balance. So we have our balanced, we don't have a balanced, we have our net ionic, oh my goodness, we have our chemical reaction. And this does not need any coefficients to balance because it's already balanced. So now your total ionic equation, we're going to start to break up what we can. So you can break up the copper sulfate to copper 2 positive and your sulfate ion, SO4 2 negative. And then on the right-hand side, your product side, you have copper solid, and then you can break apart your zinc sulfate into its ions. Okay. Then to get to our net ionic, we want to cancel out anything that we see the same on both sides or anything that's a spectator, and that will leave us with your net ionic. Now, once you have your net ionic, then we can identify what's undergoing oxidation and what's undergoing reduction. And if we have that, then we can determine our OA, or your oxidizing agent, and your reducing agent. So to start off with zinc, zinc is going from zinc with a neutral charge of 0 to positive 2. So to do that, you have to ask, did you gain or lose electrons? So we lost, so that is reduction, because that is oil, because oxidation involves loss, and we're only referring to electrons. And copper went to copper 2 positive to copper with a neutral charge, because as a solid you have no charge. And so that is a gaining of 2 electrons to neutralize that positive 2. So this would be Rig. when you're identifying your OA and RA, I already said this, but just again, you're always picking a reactant. So here we know that zinc is undergoing oxidation. And if you're undergoing oxidation, you're a reducing agent. So your reducing agent is zinc, solid. Copper is undergoing reduction. And if you're undergoing reduction, you are an oxidizing agent. So copper, the ion, 2 positive, is the OA. Now, I think there was a few more, but we'll leave it here and I will talk a little bit more about this in our next lesson that I hope to post shortly. I hope you found this helpful, and please comment and like and give me some advice. Maybe like don't have your dogs barking in the background. Sorry about that. Thank you. Bye.